Hi everyone. Today we are working on it's objective 1.8 and this is inverse functions. Okay, we are going to verify inverse functions. We find the inverse of function, horizontal line test, and much more. So what is the definition of inverse function? For example, let's consider f and g are two functions such that the f of g of x is equal x and x in the domain of g. Okay, so x in the domain of g, like this x, whatever x is, this is the domain of, in the domain of g. And if you guys pay attention, g of x is input. Well, like we have two functions, so we're gonna plug in the g of x function within the f function. Like we're gonna replace every x in the f function and we're gonna replace it with g of x. The same thing, and if we have a g and we are putting in f of x there, that's an input. This is all equal x, and x in the domain of f function. Okay, so we can also we can say the, like for example, we can rewrite this in another way. Like we can say f, instead of like g of x is inverse, pretend that's what it is equal x. And you can also say like g of x is inverse. Okay, the function g is the inverse of the function f. Like when you get the equal x, then it means g is inverse of f of x. In this case, f is inverse of g. So you can rewrite it like that. So that would be inverse f of x equal x. Now, how do we say this? This is, we read this like f negative 1, read f, oh, I'm sorry, f inverse. Yeah, so that's how we read it. Now let's verify the inverse functions. Okay, let's do some examples. So I have example number 1. F of x is equal 4x minus 7 and g of x is equal x plus 7 over 4. Now the question is asking, show that the function is the inverse of the other. Like let's show them the f of x is inverse of g of x or g of x is inverse of f of x. So let's try this. The first one, like we can say g of x, whatever is inside the parentheses, that's inverse. So g of x is inverse of f. So let's try this. If we get x like as an answer, then it means g of x is inverse of f, and then we can do the other way around, vice versa. So I have a f of x function which is right there, right? So I'm substituting for x g of x, like 4 is going to stay as a 4. For the x, I'm replacing with the g of x, like x plus 7 over 4. I already said that g of x is input, right? Like it's a regular x. So that's what I got here, minus 7. Now let's solve this. If you pay attention here, 4 and 4 cancel out. So I'm left with x plus 7 minus 7, which will give me equal x only because they cancel out. So when everything is equal x, then I know g of x is inverse of f of x. Let's try another one, the other way around. If f of x is inverse of g. So again, you know that the g function is that one, and I'm replacing this x with 4x minus 1. Whatever is inside within the parentheses, that's input. Input means you are replacing every x in g with this function. So I have x, for this x, I'm replacing with 4x minus 7. That one is plus 7 there. over 4. So I replace this x with 4x minus 7. So I know they cancel out, 4 cancel out, so I'm left with x again. So yes, that's true. So we verifies that f g of x is equal g f of x, and both of them are equal x. Verifies that f and g are inverse functions. And that's what you can do when you are verifying. Okay, so this is one example. Now let's do how to find inverse functions. This is just the verification. This was just the verification. Verify the inverse function. So how do we verify? We use this and that. If both of them are equal x, like we use g of x as an input for f of x is input for g of x, and if both of them are equal x, then yeah, they are inverse of each other. Now let's do how to find it. Finding the inverse function, in the inverse of a function. Now let's try. They said f of x is equal to x plus 7, and they said find the inverse of this function. Find the inverse. So there are a few steps that we are going to do. Step number 1 is replace f of x with y. Okay, that's my first step. So it means I have to replace this f of x with y. So I'm replacing f of x with y, and I'm going to leave everything as it is. Okay, done. Second step say interchange or switch is an easy word, switch x and y. Like wherever you see x, replace it with y, and wherever you see y, replace it with x. So I'm going to do this in this color. If I see y, I'm going to replace this with x. If I see x, I'm going to replace this with y. Plus 7 stays. Okay, so we are okay so far. Then step 3 is you are solve for y. Now, do you see this y? I have to solve for this. So how do we solve for y? Solve for y means, and I said that before several times, when this is solve for any variable, that's all they mean, that make that variable isolated, make it by itself. So I'm going to make it by itself, the y. I'm going to move this 7 first. And remember I said whatever number or goes with the variable that we are solving for, make sure you do that last. Like move that number last. So I'm going to subtract 7. They cancel out. I'm left with x minus 7 equal to y. Now again, divide by 2 because they are multiplying. So I have to do the opposite operation, divide by 2. So I'm left with x minus 7 over 2 equal y. So my y is by itself. So how do we write this? This is inverse. I'm done with 3 steps. So how do you write the answer for this? How do you write this as an inverse for this y? You're going to write f of negative 1 equal x minus 7 over 2. So like x, I forgot that. Okay. So that's how you write your answer for there. You can say your 4th step is replace y with f of negative 1x, like that. So which I did. So that's my answer for that. Okay, there is also something we talk about is a horizontal test. I'm going to move these Okay, I'm going to move those and let's see the horizontal line test. So the horizontal line test, horizontal line test. For example, if in the above examples, if they give us functions, then we can verify doing this. We can finding inverse by following these 4 steps. So if they give me a graph, then how would I figure it out if we have inverse or not? So horizontal test means if the horizontal line test, horizontal line that intersect the graph of the function f at more than one point, then it means a function has an inverse if there is no horizontal line that intersect the graph of the function f at more than one point. So let's try the horizontal thing, the horizontal line. For example, I have a graph. I'm just making it up. This one. By the way, that's the absolute graph. If this is the graph and the line, okay, and I have another graph which look like this, right? Now the question is asking which just test if they are inverse, right? These function has inverses. So if I draw a horizontal line, do you see the line is touching the graph twice? This is my, let's see, this is my figure A and this is my B, okay? So I draw a horizontal line and it touches the graph twice. If I draw a horizontal line, it touches the graph once. So it means B represent a function that has an inverse. Do you guys see that? So if the graph, the horizontal line that touches the graph once has an inverse. If it touches the graph twice, it doesn't have an inverse, okay? So I'm gonna give you some other example for the graph, and let's pay attention how these graphs are going to be there. I want to erase that one because I think I don't need that. And I'm going to move this over here and let's see. Okay, I have few order pairs, okay? And I'm going to graph those order pairs probably in this color or maybe that one. Okay, let's graph the order pair that I have for this one function f of x, okay? So I have -3, -3, -2. So I have 1, 2, 3, -3, and 1, 2. That's -2. Oh, this is too big. Okay. So this is what I got. -3, -2, 1 dot. Then I have -2 and 2 positive right there. Then I have 4 and 1. 1, 2, 3, 4, and that's 1. Okay. Now connect the dots. And I'll try my best to have a straight line. Okay, so this is my graph. It's my y equal f of x. Okay, that's my f of x function. Now let's draw inverse of this. Okay, so okay, let me write down their order pairs. For example, the f of x order pairs, the one I used just now, were -3, -2, and I use 2, -2 and 2, and I used 4 and 1. Okay, this is what I use for f of x. Now let's try the inverse of this. Now inverse means, if you guys remember the question we just did when we switched the x and y's and get the y by itself and all that stuff. So this is exactly what I'm doing. I'm gonna switch the x and y's up here too. For example, my inverse function is f inverse. I'm gonna switch the x and y's, -2 and -3, and 2 and -2, 1 and 4. Okay, so let's graph those now. -2 and I have -3. 1, 2, 3. I have 2, -2, +2 and -2 right there. 1 and 4. So I have 1 and 1, 2, 3 and 4. Okay, now connect the dots. You see, that's the inverse of that. So that's in the blue, it's y inverse. Okay, now this is how you graph the inverse functions, like switch their x and y. Simple is that. Now to verify that the graph that we just did inverse function, we verify our solution by observing the reflection of the graph about the line y equal x. If I want to verify that this is, yes, that's true what I just did, then I'm going to do the reflection of the graph about the line y equal x. So I'm going to draw a line y equal x. You know y equal x, which means x1 slope and y-intercept is 0 because it's not there. So this is y-intercept 0 and the slope is 1 and 1, right? 1 and 1. So I'm gonna just connect 1, 1 these dots. That's my line. So if you guys pay attention, the blue, the inverse is the reflection of the original f of x. Look, do you see the in reflection across this y equal x? So that's my y equal x, and you can tell this is just a reflect like a mirror. This is a reflection, right, of the f of x. So when you figure it out, the inverse, most of the time, of course, it's going to be correct. But if the question is asking how do you verify that these two, whatever graph you just drew, they are inverses of each other. So the easy way to do is just draw y equal x, and always is going to be y equal x, okay, like the line going through the origin. And then you see that's a reflection. If it's a reflection, you're good. So it means we did the correct inverse. Okay, guys, if you have any questions about this, you don't understand something, please comment below. I will help you with Zoom one-on-one tutoring. You have to just write down your name and email address in the comments, or maybe just let me know that you need a tutoring or you need a separate video for some objective, and I will do it. Please like my lessons and subscribe. Thank you so much.